the vectors. I'm doing from the 13th sum in reverse in miscellaneous. Okay, the scalar product of a vector I plus j plus k with a unit vector which is along the sum of two vectors 2i plus 4j minus 5k and lambda I plus 2j plus 3k will be 2 plus lambda into I along the sum, so you have to add it, plus 6j minus 2k. The unit vector is along the sum, but it's a unit vector, so you have to divide it by its magnitude, which is 2 plus lambda the whole square plus 36 plus 4. The scalar product of I plus j plus k with this unit vector is equal to 1. You can only dot an I and a I, j and a j, and k and a k. So it's 2 plus lambda plus 6 minus 2 is equal to root of 2 plus lambda the whole square plus 40. 36 plus 4. So this is 2 and 2 get cancelled. A lambda plus 6, so squaring both sides, a lambda square plus 12 lambda plus 36 is equal to 2 plus lambda the whole square plus 40. So we expand this as 4 plus 4 lambda plus lambda square plus 40 is equal to lambda square plus 12 lambda plus 36. Lambda square get cancelled. Take this, you get lambda. This you solve, you get minus 8 is equal to 0. 8 lambda is equal to 8. Lambda is equal to 1, and hence you found the value of lambda, and that's the question itself. Let's go to 12th question. 12th question is an A vector is equal to I plus 4j plus 2k. A B vector is equal to 3i minus 2j plus 7k. A C vector is equal to 2i minus j plus 4k. Find a D vector in such a way that D is perpendicular to A and B, and C dot D is equal to 15. Okay, this is the for this patch is a BMS sum, which is Murali Krishna and Shreyas and who's Balram, Balram Murali Krishna on a table like this, and I want to find a vector which is Shreyas vector perpendicular to both Balram and Murali Krishna, or in other words Hamdan and Aditya on the table, the two vectors on the table. You want to find a vector which is perpendicular, which is Satvik. So it's in one batch it's BMS, another batch is AHS. Okay, so then that's the sum where when you cross these two vectors you get the third vector. So you have to, when D vector is perpendicular to both A and B, which means you have to cross A and B. And to cross A and B you just have to put yjk 1 4 2 3 minus 2 7, and you can cross it, and it's I into minus j into plus k into 7 4s are 28 plus 4 2 2s are 4 minus j into 7 1s are 7 minus 6 plus k into minus 2 4 3s are 12. So it will be 32i plus 1j, no, it's minus 1j minus 14k, and that will be the vector which is perpendicular to both A and B. Okay, you have got the vector, but this may lie here when you cross it, or it may be anywhere on the table. So you have to put lambda times this to be your D vector. And you know that C dot D is equal to 15 has been given, dotted with C. C is here. When you dot it, you get 32 2s are 64 lambda plus 1 lambda. 1 1s are 1, i's and i's, j's and j's, and k's and k's with this and this. Minus 14 4s are 4 4s are 16, 4s are 56. And again lambda. And this is equal to 15. Just solve it. This will be 65 and 56 is, I think, 9 lambda is equal to 15. Lambda is equal to 15 by 9. Okay, so thus you get this answer. The question is only to find lambda or to find the unit vector. I think the question here is to find the D vector. Once you know lambda, you have to substitute it in D vector. So then the answer will be 15 by 9 into 32i minus 1j minus 14k. You can check your book back. 15 by 9 can be cancelled with 3 tables, which is 5 by 3. You can take it in and finally check your book back answer for this. So let's go to next sum. 11th question. And the direction cosines of the vector equally inclined to OX, OY and OZ This is alpha, this is beta, and this is gamma. As you all know, cos square alpha plus cos square beta plus cos square gamma is equal to 1. They equally inclined, it's all going to become alpha alpha alpha. 3 cos square alpha is equal to 1. Cos square alpha is equal to 1 by 3. A cos alpha is equal to plus or minus 1 by root 3. So then the vectors are cos alpha, cos alpha, cos alpha. No, it's no beta, gamma, and also plus or minus 1 by root 3 is one direction cosine. Other direction cosine is plus or minus 1 by root 3 and plus or minus 1 by root 3, or the three direction cosines for this sum. Let's go to 10th question. Two adjacent sides of the parallelogram. The moment they give you adjacent sides of the parallelogram, you should draw like this and like this only. And this is A and this is B. And supposing this is 2i minus 4j plus 5k. This is I minus 2j, I minus 2j minus 3k. Find a unit vector parallel to the diagonal. First of all, we have to find the diagonal. This is a diagonal. To find the diagonal, you have to construct a b vector parallel to this b vector. This is a new construction that you have to do. And this will also be I minus 2j minus 3k. No lambda times, because opposite sides of the parallelogram are same length, and so lambda is just 1. Now you know by triangle law. What is triangle law? You know, you have an a vector like this, you have a b vector like this. Yeah, the third vector will be a plus b vector. You have to just sum it up. That will give you the resultant. That's the theorem. So 2 plus 1 is 3i. Minus 4 minus 2 is minus 6j. Plus 5 minus 3 is plus 2k. This is my diagonal, and I have to, the question is to find a vector parallel to the diagonal. So lambda times 3i minus 6j plus 2k. And it's got to be unit vector. So divided by its magnitude, which is root of 3 lambda the whole square plus 6 lambda the whole square plus 2 lambda the whole square. Okay, so this is the vector, and lambda will get cancelled completely. So you get a 3i minus 6j plus 2k by root of 9 plus 36 plus 4, which is 3 by root 7 into I minus 6 by root 7 into j plus 2 by root 7 into k. Kindly check the book back answers. Okay, so I'm not doing the sum in a hurry, so I hope you get the answers correct. So let's go to next sum. So then now it's not over. Find the area of the parallelogram. Area of the parallelogram, the formula is magnitude of a cross b. When you have a and b given, you just have to cross it. So let's do cross it. I, j, k. You have to cross it with 2, minus 4, 5 and 1, minus 2 and minus 3. And how you cross it and find the magnitude. So I into minus j into plus k into I into 4 3s are 12, 5 2s are 10, minus j into minus 6 minus 5 plus k into is minus 4 plus 4. It's getting cancelled. It's 12i plus 11j plus 0k. And this is the a cross b, and magnitude of it root of 144 plus 121, which is root of 165. Root of 165. Just check your book back and just try to factorize 165. It's 5 3s are 15. 5 3s are 15. What? 3 and 11. Okay, just check your answer and write. Make sure you're writing square units. Okay, make sure you're writing square units. Try to factorize this or check your book back answer for the final answer, if in case I made any mistake in multiplying or anything. So let's go to 9th question. The position vector of R, there's a point P and Q, where P is of the vector 2a plus b, Q is of the vector a minus 3b. There is an R which divides the line PQ externally, but for me I'll put it in between. Okay, internally in the ratio 1:2. The first they're asking you to find what is your R, but you know it's actually not internal, it's external. It's 1 into this vector plus 2 into this vector by 2 plus 1, sections formula. With the plus means internal. External means 1 into a minus 3b minus 2 into 2a plus b by 1 minus 2, m into x2 minus n into x1 by m minus n. A minus 3b minus 4a minus 2b by 1 minus 2 is minus 3a minus 5b by minus 1. So it's 3a plus 5b is the vector, R vector. We found the R vector. This is R vector, 3a plus 5b. But the next thing, they're asking you to prove that P is the midpoint of RQ, which means R is here, P is here, Q is here. P is the midpoint of RQ. So it is going to divide externally. The R has to be here. That's understood now. Okay, so then write R here, 3A plus 5B. Write B here, which is 2A plus B. Which write your Q vector, which is A minus 3B. To prove that's midpoint, it's x1 plus x2 by 2. If you take these two vectors and add and divide by 2, 3A plus 5B plus A minus 3B by 2 is 4A plus 2B by 2, which is nothing but 2A plus B, which is nothing but your P, which shows that you're adding R plus Q by 2 and you're getting P, and therefore P is the midpoint. So that shows that, and let's go to 8th question. Show that the points A, B, C are collinear. This point A, B and C are collinear. Okay, where A is given to be 1, minus 2, minus 8. B is given to be 5, 0, minus 2. C is 11, 3, 7. To prove it's collinear, this length plus this length should add up to this length. The magnitude of AB plus magnitude of BC vector should add up to magnitude of AC vector, then it's collinear. First of all, we don't even have an AB vector. You only have A and B, which is x2 minus x. You find the AB vector by doing x2 minus x1 into I. 5 minus 4. 5 minus 1, 4i. 0 plus 2 plus 2j. Minus 2 plus 6. Minus 2 plus 8 is plus 6k. Okay, subtracting B minus A, you get the AB vector, the magnitude of this, plus BC vector. Again, x2 minus x1 into 11 minus 5 is 6i plus 3j plus 9k. The magnitude of this is equal to AC vector. 11 minus 1 is 10i, 3 plus 2 is 5j, 7 plus 8 is 15k. The magnitude of this should be equal, so root of 16 plus 4 plus 36 plus root of 36 plus 9 plus 81 is equal to root of 100 plus 25 plus 225. Let's check that. It's root of 56 plus root of 126 plus is equal to root of 325, 350. So you can write it as root of 14 into 4 plus root of 14 into root of 14 4s are 6 4s are 24, 6 1 6 7 8 no 14 into what is it correct what I've written? 90 36 is 0 126, yeah, and 14 into what is 126? 8 4s are 9 4s are 36, yeah, and this will be therefore 2 root 14, this will be 3 root 14, and this will be 5 root 14. The fact that they both are adding up shows that they are collinear. That's the way you have to do the 8th sum. Show that is the second part. Show that B divides AC. In what ratio is it? Okay, so A is 1, minus 2, minus 8. B is 5, 0, minus 2. C is 11, 3, 7. What ratio means? Apply it as K is to 1. You know, K into 11 plus 1 into 1 by K plus 1 is equal to 5. So 11K plus 1 is equal to 5K plus 5. Take it that side, 6K is equal to 4, or K is equal to 4 by 6 or 2 by 3. So therefore it's 2 by 3 is to 1. Or in other words, it's 2 is to 3. Thus the point B divides in ratio 2 is to 3. Please check the book back for every sum. So let's go to next sum. Is the 7th question. 7th question, A vector is I plus J plus K. A B vector is 2I minus J plus 3K. A C vector is I minus 2J plus K. Find a unit vector parallel to 2A minus B plus 3C. Okay, let's solve this. 2A means 2I plus 2J plus 2K. Minus B means minus 2I plus J minus 3K. Plus 3C means 3I minus 6J plus 3K. Just solve this. 2I and 2I get cancelled, you get a 3I. A 2J and 2J is 3J. 3J minus 6J is minus 3J. A 2K and a minus 3K will be minus K. And a minus K plus 3K will be plus 2k. So this you got this vector. And the question is about find a unit vector parallel to this. So you want to find a unit vector. It's the vector by its magnitude 3i minus 3j plus 2k by root of 9 plus 9 plus 4, which is 18 to 23 by root 22 into I minus 3 by root 22 into j, plus 2 by root 22 into k. And please check your answer, but there's a method in which you have to do it. As long as you understand the concept, you can do the sum by yourself. Find the vector of magnitude 5 units parallel to the resultant. The word resultant means addition. Okay, so it's a vector A vector which is 2i plus 3j minus k, and there's another vector B vector which is I minus 2j plus k. The resultant of A and B means A plus B vector, which is 3i plus 1j plus 0k. This is what is A plus B resultant. Now the question is find vector of magnitude 5 units and parallel to this. Anything which is parallel to this will be okay, let's convert into unit vector. A unit vector will be 3i plus 1j plus 0k, forget it, by root of 3 square, which is 9 plus 1. So 3 by root 10 into I plus 1 by root 10 into j is the unit vector. But here they are saying the magnitude is 5 units. So just multiply this whole thing with a 5. Unit vector multiplied by 5 will give you 5 units. So 15 by root 10 into I plus 5 by root 10 into j. They would have probably rationalized the answer. You can check that out. So let's go to next sum. That's fifth question is find the value of x for which x into I cap plus j cap plus k cap is a unit vector. This itself is a unit vector. You don't have to convert it into unit vector. They're given that this vector itself is a unit vector. The magnitude itself is unity. Root of x square plus x square plus x square itself is 1. Root of 3x square is equal to 1. 3x square is equal to 1. X square is equal to 1 by 3. So x is equal to plus or minus 1 by root 3. So that's the value of x. So let's go to next question, which is the fourth question. If A vector is equal to B vector plus C vector, the magnitude of A vector is equal to magnitude of B plus magnitude of C. Is it true? Okay, you know, when B vector is like this and a C vector is like this, when they travel along the same line, then when the magnitude of B plus magnitude of C will obviously be equal to the magnitude of A. But what happens if B vector is like this and a C vector is like this? The magnitude of B and magnitude of C will not be the same as magnitude of A. The magnitude of A will be lesser than magnitude of B plus magnitude of C in this case. In this case, magnitude of A will be equal to magnitude of B plus magnitude of C. Therefore, the combined statement is magnitude of A is lesser than or equal to magnitude of B plus magnitude of C. So this is displacement. Okay, in straight line, the distance is equal to displacement. Distance is equal to displacement. Displacement is the change in the position from the beginning to the end. Beginning to the end is straight line motion. Displacement, distance are equal. Whereas in a triangle, you see the displacement is shortest length here, not this. Whereas the distance is this plus this, so it's not the same. So that's about this sum. Let's go to next question. Is a girl walks 4 kilometers towards the west. So this is east west. Girl walks north south 4 kilometers towards the west and takes an turn and walks 3 kilometers in the direction east of north, 30 degree east of north. Of north towards east is 30 degree, okay, which means this is obviously 60 degree. This angle is 60 degree. She stops there. You have to find the displacement. Displacement is a change in the position from where she started. She started from 0i plus 0j. You need to find what is the coordinates there, for which you have to treat this distance as x and this as 4 minus x. You have to take this triangle and write what is cos 60. Cos 60 is equal to 4 minus x by 3, which is nothing but cos 60's value 1 by 2. So 8 minus 2x is equal to 3. 2x is equal to 5. X is equal to 2.5. So you got the x coordinate 2.5. To get the y coordinate, you get sin 60 is equal to opposite by 3. Sin 60 is also root 3 by 2. Therefore, opposite is 3 root 3 by 2. Therefore, you got this to be 3 root 3 by 2. So you got it 5.5 by 2 and 3 root 3 by 2, and this displacement therefore is x2 minus x1 into I plus y2 minus y1 to j, which is 5 by 2 into I plus 3 root 3 by 2 into j is what is it? Displacement. If they ask you distance, you know it's 4 plus 3, the entire distance you would have traveled. Okay, so then that's about this sum. Let's go to second sum. The scalar component of and the magnitude of the vectors joining the points. Okay, there are 2 points. Okay, this point is P, which is x1 y1 z1. This point is Q, which is x2 y2 z2. To get this vector, it's x2 minus x1, y2 minus y1, z2 minus z1. The vector is x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k. The scalar components means direction ratios. It's just x2 minus x1 comma y2 minus y1 comma z2 minus z1, all the scalar components. They are asking for the magnitude of the unit vector, this vector by its magnitude. So x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k by, did they ask you the unit vector? No, they're just asking you for the magnitude of it. So root of the component square, so root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square is the magnitude of this vector. So which is the magnitude of PQ vector. These are called the DRs, direction ratios. So let's go to first sum. Write down a unit vector in xy plane. So draw an xy plane. A unit vector which makes an angle 30 degree with x-axis means it's obviously 60 degree with the y-axis. Therefore, you know cos alpha into I is cos 30i, cos beta into j is cos 60 into j. And cos 30 is nothing but a root 3 by 2 into I. Cos 60 is nothing but 1 by 2 into j. And can you imagine, this is definitely unit vector. Find the magnitude. 3 by 4 plus 1 by 4 is root of 4 by 4. So it satisfies unit vector condition. So that's about this. Next is miscellaneous example. It's example 30. Example 30, which is a very very important sum, where there's an alpha which is 3i minus j. There's a vector which is 0k obviously. A beta which is 2i plus j minus 3k. And they've given that beta is equal to beta 1 plus beta 2. Where beta 1 they've said is parallel to alpha. So it's very easy to write beta 1, which is lambda times 3i minus j, or a 3 lambda I minus lambda into j. But beta 2 is perpendicular to alpha. You can't write that. This is where you'll get stuck. Therefore, remember beta 2 is equal to beta minus beta 1. Beta is 2i plus j minus 3k minus beta 1 is 3 lambda I minus lambda j. So consolidating the i's and i's, 2 minus 3 lambda into I plus 1 minus lambda into j minus 3k is a subtraction where you get beta 2. Now you know what is beta 1, you know what is beta 2. But here's it's given that beta 2 is perpendicular to alpha. Remember this one. So then you got beta 2. Now dot product with alpha. So it's 3 into 2 minus 3 lambda minus 1 into 1 minus lambda plus 0 into anything is 0. So is equal to dot product is equal to 0. For perpendicular vectors, dot product is equal to 0. Beta 2 is perpendicular to alpha. So beta 2 dot alpha is equal to 0. 6 minus 9 lambda minus 1 plus 1 lambda is equal to 0. A 5 minus 8 lambda is equal to 0. 8 lambda is equal to 5. Lambda is equal to 5 by 8. I don't know if my answer is correct. Lambda is wrong. It's definitely wrong. So what is the mistake? 3 into 2 minus 3 lambda minus 1 into 1. This 1 plus lambda here. It's 1 plus lambda here when I took it in. That's a mistake. Okay. So when you solve this, when you take it in and solve, you'll get lambda is equal to 1 by 2. Once you get lambda, put it in beta 1 and beta 2 and find your final answer. Very very important question. So let's go to example 29. Example 29 is given that a vector plus b vector plus c vector is equal to 0. You have to find a dot b plus b dot c plus c dot a. Whenever they do that, a, b, b, c, c, a will come only when you whole square it. So take it as magnitude of a plus magnitude of b plus magnitude of c is equal to 0. Squaring both sides, magnitude of a the whole square, magnitude of b the whole square plus magnitude of c the whole square. So 2 times. 1 second, hold on. So 2 times a vector dot b vector plus 2 times 2ab to bc plus 2ca itself is 0. So magnitude of a is given in the question that magnitude of a is equal to 3. So it become 9. Magnitude of b is equal to 4, 16. C is 2, so 4 plus 2 times a dot b plus b dot c. That's what you want, plus c dot a is equal to 0. So then this itself is 29 plus 2 into, let's keep this as some x is equal to 0. The x is equal to minus 29 by 2. Therefore you got a dot b plus b dot c plus c dot a. Let's go to example 28. Example 28 is ABC of 3 vectors where magnitude of A is equal to 3, magnitude of B is equal to 4, magnitude of C is equal to 5, and each of them is perpendicular sum of the other two. A is perpendicular to B plus C vector, which means dot product of this will be 0. B is perpendicular to C plus A, and the dot product this will be 0. C will be perpendicular to A plus B, and the dot product of this will be 0, which means it's A dot B plus A dot C is equal to 0. This implies B dot C plus B dot A is equal to 0. This implies C dot A plus C dot B is equal to 0. So when you add them, you get 2 times AB plus BC plus CA itself is 0. Okay, now coming back to the question, what are they asking? They're asking you to find magnitude of A plus B plus C. And I've told you, whenever they give you like this, so I've taken square it, magnitude of A the whole square plus magnitude of B the whole square plus magnitude of C the whole square plus 2 times AB plus BC, 2 times AB plus BC plus CA, which itself is 0. Therefore, the answer is magnitude of A the whole square, which is given to be 3, so 9. Magnitude of B is 4, so 16. Magnitude of C is 5, so 25. So it's 25 plus 25, 50 is what is magnitude of A plus B plus C, the whole square. I have actually squared it. The question is only about magnitude of A plus B plus C. Therefore, it will be root 50. Or at 25, so it's 5 root 2. So that's about it. Let's go to the next question, which is the 27th example, wherein they've given 1, 2, 3, 4 vectors. The position vectors of A, B, C, D have been given. Find the angle between A, B and C, D. So let's write that. What is A vector? A vector is being given as I plus J plus K. A B vector is given as 2I plus 5J, which means plus 0K. Okay. A C vector is given as 3I plus 2J minus 3K. A D vector is given as I minus 6J minus K. So you have A, B, C, D to be the different vectors. They are asking you to find the angle between A, B and CD, which means you need an AB vector and a CD vector. Okay, and you know the cos theta angle between two vectors is this vector dot this vector by magnitude of this vector into magnitude of this vector. So you need an AB vector. How to find an AB vector is B minus A. So let's find 2 minus 1 is 1I, 5 minus 1 is 4J, 0 minus 1 is minus 1K. That is your AB vector. What is your CD vector? Which is D minus C. X2 minus x1, so minus 2I minus 8j plus 2k. By magnitude of this is 1 plus 16 plus 1. The magnitude of this is 4 plus 64 plus 4. So then therefore dotted is minus 2. I's and i's, j's and j's, 8 4s are 32. K's and k's is minus 2 by root of 18 into root of 72. So when you calculate this, you'll get an answer minus 36 by 36, which is minus 1, which shows the theta is equal to 180. Okay, so let's go to next sum, which is the first sum in miscellaneous example, where they're asking you to write a unit vector in xy plane. Xy plane, unit vector, if this is alpha, you all know this is beta, which is also 90 minus alpha. Yeah, the cos alpha into I plus cos beta into j can also be written as cos alpha into I plus cos 90 minus alpha into j. So cos alpha into I plus sin alpha into j. Thus you got a unit vector, because cos square alpha plus sin square alpha is always 1. If you keep it like this, you cannot prove it as unit vector, so you have to convert it necessarily like this. I hope you all clear. Yeah, please practice.